All right, welcome back, everybody, to the Python Primer for Student Researchers. Today I wanted to talk a little bit about vectors and matrices, in particular using numerical Python in Python 3. So I'm going to go ahead and start a new Python 3 notebook. And the very first thing we're going to need to do to talk about vectors and matrices is we're going to have to import our NumPy library. So I'm going to go ahead and do that. Say import NumPy as MP. And that's going to import our numerical Python libraries, and I'll be able to access those. Now, we're going to start with talking about arrays, and arrays are very similar to lists. We've already talked about lists in Python. Lists are ways to collect data together into a container that you can access under a single variable name. Arrays are a little bit different from lists in the sense that they have a fixed size and they have a specific data type. So lists, as you recall from last time, you can put anything you want in them. You can put strings, floats, integers, functions, images, anything you'd like. You can add and subtract members of the list as you go, so the list can get larger and smaller. That takes up a lot of memory and it takes up a lot of resources in your computer. So when you're doing numerical calculations, especially with large arrays and large matrices, you would like to make that faster and use fewer resources. So the way we do that is by telling the computer ahead of time how big the array is and what type of data it is. And then that way it can allocate a certain amount of memory and it doesn't have to do any overhead to try and figure out how much information to store on the computer. You'll find that you access the information in the arrays very similar to lists, but they are different in the sense that they have a fixed size and they have a fixed data type. I'm going to go ahead and start by defining my array. And my array I can define by just saying mp.array and then putting a list inside of it. So 1, 2, 3, 4. And if I print that array, you'll see that it looks very similar to what we got when we did a list. Now let's show you the difference there. If I do 1, 2, 3, 4 with my list, and then I print that list, I still get 1, 2, 3, 4, but it has a slightly different notation because this is a list of elements in Python. I can convert that list to an array by just saying mp.array and putting that list inside. And if I print that out, you'll see array out, you'll see that it looks like just the array up here. So there, if you oftentimes it's handy to collect information into a list because, say, for example, if you're reading a file, you don't necessarily know how big the file is, you won't know how many elements you have. But as soon as you know how big your list is going to be, you can convert it into an array for use in Python. So the one thing I want to show, if you're curious whether you have a list or an array, is you can print out its type. So I can say print type and put the list in here. And you can see that that tells me that that's a list. Or if I print out the type of my array, you can see that that's called a NumPy ND array. So if you're wondering whether or not you're working with a list or whether you're working with an array, you can tell that. Okay, so once you've got, let me go ahead and delete these. And by the way, there's a shortcut for deleting these cells. If you select it on the outside and hit DD, it'll just delete the cells as you go back up, so you can clean up your notebook a little bit. All right, so I've re-imported my NumPy library, and we want to talk a little bit about the different types of arrays that we can have. To put this in terms of some of the things you've seen in your science courses, the first thing we want to talk about is a scalar, which is a special type of array that has 0 dimensions. So I'm going to make a variable called myScalar, and I can define that as an array. I can say mp.array, and then just put a number in there. And if I print that out, and I want its value, but I also want to check how many dimensions it has, I can say myScalar dot ndim. So it's going to tell me how many dimensions that has. So that tells me that this is an array with a value of 10 and has 0 dimensions. So by definition, a scalar. So you can use that ndim property here to check to see how many dimensions that has. And Python's just going to treat that like a regular number that's going around. And it's going to interpret these things as floating point or integer, but you can specify that by saying dtype equals float. And then that's going to change that into a floating point. So if you want to be very specific about your types, you can also put int in here and it'll turn it to an integer. So using the dtype keyword, you can specify what type you might want in there. Typically, I just set that as a float, or oftentimes, I'm multiplying by their floats and it's not going to matter. All right, so now let's talk about one-dimensional arrays, things that we typically call vectors. So I'm going to define a vector, and in physics at least, oftentimes vectors are a one-dimensional vector with 3 elements, x, y, z, or vx, vy, vz. So I can define that with mp.array, and then I put 3 values in there, 1, 2, 3. And if I print that out, with its dimensions, so I can see what that looks like, I get 1, 2, 3, and it has dimensions of 1. So I have a vector, so it's a one-dimensional array. This has 3 values. Now, vectors don't have to have 3 values. In fact, they can have as many values as you want. And oftentimes when we're dealing with lists of data, we are dealing with, a vector of times, for example, or a vector of positions as a function of time. So these can be as long as you want. But typically when we're talking about one-dimensional vectors, we're talking about them having 3 values. Now I can also do multi-dimensional arrays. So for example, if I've got a 2x2 matrix or a 3x3 matrix, I can define those using the NumPy array as well. So I can say my array is equal to mp.array, and instead of putting in one value, one sequence of numbers, I put in 2. Now here's where the notation gets a little bit different, because what I need to do is I need to do basically an array, a one-dimensional array of one-dimensional arrays. So what I'm going to do is I'm going to put in open close bracket, and then inside of that I'm going to do open close bracket, comma, open close bracket, and then here is where I'm going to put in the values for my 2x2 array. So that's going to give me a 2x2 array where the first row is 1, 2, and the second row is 3, 4. And so if I print that and I do the size of that, we'll do ndim to see what the dimensions are. You can see that that is an array that has rows 1, 2, 3, 4, and it has 2 dimensions. And you can go up and up and up. You can have arrays with as many dimensions as you want. Of course, once you get past the 2-dimensional arrays, it becomes a little bit more difficult to set it out on the screen, but you can have n by n matrices as big as you like. Okay, so now how do I access those elements, right? So we're familiar with accessing list elements. So for example, if I say my vector 0 and I want to print that, then that's going to give me the first element of vector 0. But how do I deal with this 2x2 array? Well, I can just say print my array, and now I have 2 indices, right? So I've got the first index and the second index. And the first index is going to refer to the row, and the second one's going to refer to the column. If I do 0, 0, that's going to show me the number 1. If I do 0, 1, that's going to show me the number 2, because it's this element right here. If I do 1, 1, that's going to show me the element 4 right here. And if I do 1, 0, that's going to show me the element 3. So this is 0, 0, 0, 1, 1, 0, 1, 1. Okay, so we can access the array elements that way. Okay, so let me go ahead and delete these real quick. Let's talk about initializing your vectors, because Python has to know the size of an array before you can do anything with it. If you're doing some sort of calculation and there's going to be, for example, you know what the array of times look like, and you know what the array of positions look like, you need to define the arrays of your velocities or whatever before you do those calculations. So let me just show you a couple of ways of initializing empty arrays. So you can see how to do that. So the first thing I want to do is I'm going to create a 2x2 array that has no values, or I should say has 0 as its value. So I'm going to say my array, and I say that's equal to mp.zeros. This is a function that we can use. And I say I want to get a 2x2 array, and I want the type to be float. So I want a 2x2 floating point array where every value is 0. And if I look at this, there it is. So I've got an array that's empty right now, but I'm going to can do calculations later to fill that up. And I can make this as big as I want. I could make it 300 by 300, which is going to be enormous. Now you'll notice it's eliding these things by using ellipses. It's not going to show you a whole 300 by 300 array, but you can go to as many dimensions as you want. And when you do that, it's going to show you this matrix, which is now a 300 by 300 by 300 by 300 dimensional array. And once you start getting to arrays of that size, it's good to go ahead and also print out the dimensions so you know how big it is, because this has a lot of dimensions and it's a 4-dimensional array. And you can see that printing out the values of these things is not that useful. So that's where oftentimes it's better to just look at the type and the dimensions to keep track. We're looking at a 4-dimensional NumPy array. You can even do the length of these things and look at the size of the dimensions. But that tells you how you can basically define dimensions of any size as much as you like to go. Now, oftentimes for calculations in Python, what we're going to do is we're going to have some function or value that is, say dependent on time, and we're going to start with an array of times and then calculate everything else from that. So for example, I might say that a time series is an array, but I just want it to go from, say, 0 seconds to 10 seconds in increments of some 0.1 seconds, let's say. So what I can do is use a function called Linspace, and I say start at 0, go to 10, and give me, say, 101 points. And then I'm going to print those out there so you can see what that looks like. And when I do that, you can see that what this does is it gives me 101 data points from the value 0 to 10. And because of the way I chose that, it increments it by 0.1. So I've got 0, 0.1, 0.2, all the way up to 10. That allows me to be able to do calculations now where I can calculate things based on that time. And this is where arrays really get cool, because rather than having to loop through all those values or do all those values independently, because it's an array, I can now do array calculations. So I can do calculations on the entire array all at once. For example, if I wanted to figure out, say, how far a ball dropped as a function of time, I can define my gravity as equal to minus 9.8. And then I can just say, well, the distance it drops is just going to be equal to 0.5 times gravity times squared. And that is going to calculate the distance for every single one of those times in that list. And so if I print distance here, I'm not going to get a single number. I'm going to get a list, which is showing me the position below 0 of that object all the way down. After 10 seconds, it's dropped almost 500 meters, which I think is pretty cool, because under normal circumstances, if you were thinking about doing this in your calculator, if somebody said, oh, well, what's the position at time of 5 seconds? Well, you'd have to put in 5 seconds, multiply by gravity, blah, blah, blah. But because I made an array, and because Python knows it's an array of numbers, it just goes ahead and does this calculation for you. And it even converts the distance automatically into a 1-dimensional NumPy array. So that does that automatically. So this is probably one of the most powerful things of using numerical Python. You can do calculations like this in basically 2 lines, which is pretty cool, I think. Just to give you another example of what this might look like, I can define a sequence of angles. And let's say I don't want to go from 0 to 100. Instead, I want to go from 0 to mp.pi. And let's see what that does for us. This defaults to a certain set of values. Now I can get more of those or less. If I type, let's say I want 1,000 increments, right? It'll go and give me as much or as little as I want, but there is a default value. So you can just say, do that. So this gives me an array of values from 0 to pi, and I'm using the mp.pi because I've already loaded in MP. Most of the math functions you use in math also have equivalents in MP, but I'm doing this because when we do calculations with functions, we need to use the numerical Python functions because they'll operate on the entire matrix or the entire array. So I can say the result, for example, of the cosine of those things. I can say mp.cosine of my angle. And again, in one line, it's going to give me the value of cosine for every single one of those values of the angle. So what would normally be one calculation, one number, because we're using the numerical Python arrays, becomes the calculation over all of those, and it happens almost instantaneously. So this is one of the most powerful things about using arrays, and it's something that if you were to try to use lists in Python, you'd have to use for loops and all these things to loop over these. But if we use numerical Python and use these arrays, we can very much shorten up our code. And this is also really handy, if you're rather than just trying to test a function at one angle, you can test it at all angles. You can even graph it and make sure it looks the way you want. Okay, so that's all we've got for today, looking at vectors and matrices. Next up in our programming concepts, we're going to look at conditional statements and loops. We'll see you over there.